Hello guys, today we are looking at a new problem, and the problem is to find the minimum depth of a binary tree. And it also defines us the minimum depth of a binary tree. It is the shortest path along from the root node down to the nearest leaf node. So there must be a leaf node, keep this in mind. Um, for example, this is a binary tree, and you can see the shortest path is from 3 to 9, which has a depth of 2, and therefore the output is 2. That's the minimum path. But if you choose to go to the right, then your depth is larger. That's simple enough. Actually, we have done a very similar problem to this problem before as well. It was the maximum depth of binary tree. And in there, we solved this using recursive method. You can see on the right, we had one function, and we're checking if the root is none. In that case, the depth is 0. Otherwise, we are finding the maximum depth of left subtree and right subtree, recursively calling the same function, and then finding the maximum between those two depths and adding 1 to consider the current node. And this was the solution of maximum depth problem. At first sight, if you change this maximum to minimum, you might think that that's our solution, but that's not it for minimum depth problem. Because on your right, as you can see, the problem is slightly more complicated. And let me explain you with another example. So let this be a binary tree which don't have anything on the left hand side, right? Now on the right hand side though, there is quite a lot of depth to it, but on the left hand side, there's nothing. And you might think that the output or the answer for this is 1. The minimum depth for this binary tree is 1, but that's not true. As you can see, output is 5, which is which seems to be like a maximum depth here, because 1, 2, 3, 4, 5. There are 5 nodes to the right hand side, and they're all being accounted when you're calculating the minimum depth. And the reason for that is that definition we had earlier. It is the shortest path from the root node down to the nearest leaf node, which means that there must be a leaf node. In the example I just showed you, there is no leaf node on your left subtree. So there's no there is no depth of 1 on your left hand side. You have to go to the right. So that's something that you have to consider when finding the minimum depth of a binary tree. Because in this program, if I change this maximum to minimum, then there's something to note. The left depth for this particular example is going to be 0 in this program, because there's nothing there, and therefore when I take the minimum of left depth and right depth, we're taking the minimum between 0 and something, and it's going to be most likely 0 here, right? And so 0 plus 1 is always going to be 1. So in this program, in this problem example, we are going to have the program is going to output 1, but the actual output should have been 5. So this is not a way to solve our problem. We have to handle such situation, and therefore in this problem I've handled such situation in these conditions. You can see I first handle when the root is none, I want to return 0 because there are no nodes. And when both the left hand side and right hand side doesn't exist, that's a leaf node, so I'm returning 1 there. I've also handled a situation where the left hand side, this left subtree does not exist, but right subtree does exist. In such situation, I want to focus on the right hand side, and I'm adding +1 to consider the current node, right? Similarly, if the right hand side does not exist but left hand side exists, I want to go down the left hand side, and I'm adding 1 to consider that particular node we are currently in. So I've handled all those situations which we have just considered in this particular example, when there is no subtree or there is no leaf node, basically. And then in else condition, it is exactly the same logic we've used in the max depth of binary tree. I've uh, I've computed the depth on the left subtree and right subtree by recursively calling the same function and then returning the minimum between the two depths, and I'm adding one to consider the current node, and that would be our solution. I could submit this and this should be just fine. Oh, seems like I have two NAND. Alright, that's the solution. Thank you.